Okay. Hey y'all, we are going to do another example of finding an inverse. Let me see where this is. Okay. So let me do this. We're still finding an inverse here, okay? Say what we are given is f of x equals x plus 2 over x minus 3. And it tells me to find the inverse of this function. Well, I know that my first step is to switch my x's and my y's, and all I'm looking at are x's. So I need to remember that f of x is the same thing as writing y. So I'm actually going to go ahead and change that to y equals x plus 2 over x minus 3. Okay, now it's the same original function that they gave me, but instead of f of x, I wrote y, because those are equivalent. Now, what I'm going to do is that first step, which told us to switch my x's and my y's. So what I get is x. It's kind of wonky looking. What I get is x equals y plus 2 over y minus 3. Okay, so this is now the equation that I'm using to solve for y. If y'all are okay with it, I'm going to rewrite it on the left-hand side right here. This is what I'm solving. X equals y plus 2. I'm actually going to scoot it over just because I know what I'm fixing to have to do. X equals y plus 2 over y minus 3. Okay, my directions tell me to solve for y. Well, currently I have a y in a numerator and I have a y in a denominator, and that's not going to help me solve for just one single y, right? So what I need to do is actually get that y minus 3 out of the denominator, and the way you do that, because this is division, we would use the inverse, which is multiplication. And what you do to one side, you have to do to the other. So I'm going to multiply both sides by my denominator. That way, on my right-hand side, it cancels. So I'm still moving to the right, y'all, okay? On my left-hand side, you notice that I have y minus 3 times x. I'm going to write that as x times y minus 3 equals. Now, on my right-hand side, do you agree with me that this can be written over 1? Okay, good, because it can, and that might help you see this. Technically, what I have here is a y minus 3 in the numerator, written in blue, and a y minus 3 in the denominator, written in black. And if I have a pair of things, one on top, one on the bottom, that have common factors, they can cancel each other or reduce each other, right? Well, y minus 3 and y minus 3 are the exact same thing, and so they actually end up canceling each other. What I'm doing is using the inverse, and technically it just became a number 1, but we don't have to write that because it's a number 1 and we're dealing with multiplication. Anything times 1 is just itself, right? So what I have here on the right-hand side now is just y plus 2, which is great. I no longer have that fraction. Now the only issue that I run into is the fact that I've got a y on the right-hand side and I've got a y on the left-hand side, and on the left-hand side it's inside of parentheses. So that's definitely not going to help me at this moment to solve for just my y. So what I need to do is just recognize that the x multiplying that parenthesis right there with the y minus 3 in it, that has to be solved first. And so you actually are going to distribute it inside of the parentheses. So basically what we're doing is we're multiplying that x to both of those terms individually. So if you do x times y, what we get is xy. And then if you do x times 3, you get 3x. Signs are different, so it's negative. And then we have our equal sign, y plus 2 on the right-hand side. Okay, I'm getting a lot closer to solving for my y variable. I know that in order to solve it for my y variable, I just need to have y isolated alone on either side of the equal sign. So I notice that I've got one on both sides. I'm going to move whatever doesn't have an x away. I'm sorry, a y away. And what does have a y, I'm going to move them together. So this is what I notice. I notice that I have a negative 3x. If I do the opposite here, I need to do the same to the other side. So I would be adding a 3x over here, correct? And then I notice that I have a positive y on the right-hand side. So I'm going to go ahead and move that, which would be a negative y. So right here, we're just going to kind of look and see. Things can only be combined if they're like terms. Looking at my x, y in black and my negative y in blue, those are not like terms. Those cannot be combined in any way. So I would just have my xy and my negative y. And then right here, I have a negative 3x plus 3x. Those canceled each other, which is good. That's what I wanted. That was me using the inverse. I have my equal sign. And then on the right-hand side, plus y minus y goes away. Now I have a positive 2 and a positive 3x. Those are not like terms. Those cannot be combined in any kind of way. So all I have is 3x plus 2. What you'll usually do is write it, any of your answers with the exponent in descending order. So that's why that 3x would technically, it'd be better to write it first instead of your 2. And let's see, I'm not done yet because I've got multiple y's and my goal was just to solve for one y. I do notice though, if I look at both of these terms, each of them have a y in common. So I'm actually going to pull out their greatest common factor, which is a single y. What I mean by that is we're going to actually divide both of those terms by the common factor of y. Now, y'all, if you do x, y divided by y, the y's cancel, right? And what you're left with is x. And then if we do y divided by y, anything divided by itself is just 1. Their signs are different, so my quotient is different. The answer I get there is going to be a negative. I mean, I said it's going to be different. It's going to be negative. And then we have our equal sign, and then we have our 3x plus 2. Okay, I'm literally almost done. I need to solve for y alone. The good thing about taking out that greatest common factor was now that I have y multiplying this set of parentheses, I know I always say if you have a number there, distribute it in. But if you do that, you're going to end up back at that step, which is not where we want to go. We just need to notice we want y alone. And because y has something multiplying with it, you would do the inverse, which is to divide it by the exact same thing. What you do to one side, you have to do to the other. It's always a balancing game. Now, on the left-hand side, I have my y, and those canceled because anything divided by itself is just 1, right? And then we have equal. And then on my right-hand side, I have 3x plus 2 over x minus 1. So this is what you would call the inverse of f, or you could say F inverse. Right there. Okay, awesome. Y'all let me know if you have any questions, okay? Thanks. Bye.